So this is version B, but all you have to do is find this exact question on your test. If you have version A, find the exact question on your test, because they're all the same questions. They were just scrambled. Has anybody found this one? On version A? It's not number 1, obviously. Okay, so number 1 on version B is number 7 on version A. Okay, number 7 on version A. So if you're on version A, turn to number 7, and you could work this out as I work it out. If you're on version B, then let's do number 1 together. Now, the first type of factoring that we learned that you should always try is pulling out the GCF. So is there anything in common in the first, or in all 3 terms? What multiple is in 18, 15, and 18? 3. So everybody should have pulled out a 3, and what would be left on the inside? 6h squared plus 5h minus 6. And now on the inside of the parentheses, we have a quadratic trinomial. Unfortunately, it still has a 6 right here, okay? Which means we have to do that long process, a times c. So let's do that. Step 1 is to multiply a times c, and that would be 6 times negative 6, which would be negative 36. So step 1, we get the answer negative 36. Step 2 is to think of the multiples of negative 36, like negative 1 times 36, negative 2 times 18, negative 3 times 12, negative 4 times 9. Those are all the possibilities besides, oh, wait a minute, negative 6 times 6. Besides changing the sign, those are all the possible multiplication problems that give you negative 36. Now, which pair of numbers combines together to give us the middle value 5, the b value 5? Anybody? Come on. We're awake, it's Monday. Negative 4 and 9, if you add those together, you really do get the b value 5. Okay, now remember, we are ignoring, let me put a little something right here. We're ignoring this guy, the 3. Put a box on it just so we don't look at it for now. We're going to bring down the 3 on our answer at the very end. Now, at this point, step 3, you could rewrite the trinomial as a polynomial by replacing the positive, the 5h, replacing it with negative 4h plus 9h, and then factor by grouping. But that honestly is the longer way of doing it. There's that shortcut I showed you on Thursday where you could already just write your answer format. Now, what belongs in the first term and the first term? It's not just h, because h times h would be h squared. It's 6h, right? Which is weird because 6h times 6h is not 6h squared. It's 36h squared. But at the end, we're going to reduce the binomials with their GCFs to get rid of one of these 6's, all right? Anyhow, that's how you start that shortcut. And then you simply take your negative 4 and you put it right here, and the positive 9 and put it right here, and you're done. Well, almost done. So put the negative 4 right there, the positive 9 right there. This is a lot faster than grouping. Now, at this point, all you have to do is see if there's a GCF in each of the binomials that you could reduce the binomials by. So on the first binomial, the 6 and the 4, you could divide both of them by what? 2. So if you divide both by 2, you get 3h minus 2, and that is the binomial on your answer. How about the other binomial? We're going to divide it by 3. That's right. So our answer is going to have a 2h plus 3. And let's not forget, let me uncover this guy. Remember this 3 out here in the front? We need to just slap it right here in the front. So I'm going to take this 3 and put it right here. And ladies and gentlemen, that is the final question, or final answer on question number 1. This is as hard as it gets. Let's move on. So number 2 on version B is number 6 on version A. Okay? So if you're on version A, go ahead and turn to number 6. And let's explain this one. Once again, we are going to pull out the GCF. And the GCF is what? 2. There's a 2, a 10, and a 12. There's a multiple of 2 we could pull out. If we pull out that multiple of 2, we'll have b squared plus 5b plus 6. And now we look at the inside of the parentheses, and we see that it's b squared plus 5b plus 6. There's no more number. There's no more a value in front of the b squared. I mean, the a value is 1. But we love it when there's no number in front of the b squared because we are able to just plug it right in with a b and a b. And all we do there is think the shortest way of factoring. What times what is 6? That if you add it together is 5. 3 times 2. So if you put a plus 3 and a plus 2, or you could do it the other way around, plus 2 plus 3. And let's not forget about that outside 2 that belongs right in front of it. There's our answer, guys. 2 parenthesis b plus 3, b plus 2. Easy peasy. Let's move on to number 3 on version B. So we're on number 3 version B, which is number 5 on version A. And as you can see, guys, there's a 6 right here in front. What that means is I cannot do this, m times m. I can't. Because m times m is m squared, not 6m squared. Okay? So this is not going to work for us. We cannot think what times what is negative 3, that if we add together 7, it just doesn't work that way. Because there's a 6 right here, we have to follow the steps. So, you know what? I'll leave those parentheses there since our factored form is going to be in that. It's going to look like that. So let me just go to the steps. Step 1 is a times c. What's a times c? That's 6 times negative 3. That's negative 18. Step 2 is to think of the multiples of negative 18, like negative 1 times 18, negative 2 times 9, negative 3 times 6, and that's about it. Now, we want to find which pair of numbers combines together to give you the b value, which is 7. 9 and negative 2, that's right. So this is the pair of numbers that we want, and if we add them together, negative 2 plus 9, it really is positive 7. So we don't have to do any sign change or anything. Now at this point, we could jump to our answer format. I always say put the parentheses, and then we simply put this term on both parentheses, but we ignore the 2. We just put 6m. Okay? So you put 6m, you put 6m, and then you take the pair of numbers that you just had from step 2 and put that negative 2 right there, and then put that 9 right there, positive 9. And then after that, you simply reduce each of those parentheses. So that first parenthesis, there's a GCF there of 2. You could divide by 2, and your answer will be 3m minus 1. And the other one, you could divide by 3, 2m plus 3. And that's it. We could go back up to number 3 and put that 3 right in front right there, minus 1. Put that 2 right in front of the m, plus 3. That's the factored form right there, guys. So number 4 on version B is number 4 on version A. Again, you're always supposed to try to pull out the GCF. 8, 5, and 10, there's nothing in common. Can't pull out a 2, can't pull out a 5. So we have to use those steps. Step 1, multiply a times c. That's 8 times negative 10. That will be a negative 80. You take that negative 80. Step 2 is to make a list of the multiples of negative 80 that combine together to give you negative 5. I'm going to go for it here. Negative 1 times 80. Negative 2 times 40. Negative 3 is not going to work. Negative 4 times 20. Negative 5 times 15. Negative 6 times 6 doesn't work. 7 doesn't work. Negative 8 times 10 is also negative 80. Those are all the possible multiplication problems that give us a negative 80. Which pair of numbers combines together to give us this middle value, negative 5? Anybody? If I add negative 8 and 10, do I get negative 5? No, I get 2. That didn't work. If I add negative 15 and negative 5 and positive 15, that gives me 10. Does not work. So as I look at these possibilities, none of them work, right? So we just say prime. Let's move on, number 5. You could have also written not factorable. All right, number 5. That's huge. That's disgusting. There's a lot of terms. Now the question is there a GCF I could pull out of every single term? 12, 3? Nope, it doesn't work. Not even A's? Nope, not even B's. Okay, so there's nothing I could pull out. So since there's 4 terms, we're going to try to factor by grouping. So the first thing to do is make space. Second thing to do would be to factor something out of your first group. And what's in common in those 2 terms right there? 3 and an A, because there's A's in both of them, right? So if I do pull out a 3A, what will I have left on the inside? 4A minus 5B. Okay? And the other one, what could I pull out? A 4. Okay. Now, if I pull out a 4, on the inside, I'll have a negative 4A, but I don't want a negative 4A because the other one's positive, right? So instead of pulling out a regular 4, I want to pull out a negative 4. That's a better option. Pull out a negative 4. That way you get the same positive 4A right there and negative 5B over here. And then you could recognize that there's a binomial in common in the first group and in the second group that we're going to pull out, factor out, and put it out here in the front. And if I do pull out that 4A minus 5B, then obviously this 3A just comes down and this minus 4 just comes down. So 3A and minus 4, they come down, and that'll be your binomial over here, 3A minus 4. And that is your factored form answer. By the way, this was on version A, it was number 3. It's number 2? Okay, sorry. Version A, number 2. Let's move on, number 6 on version B. So this one on version A is number 3. So if you're on version A, turn to number 3. If you're on version B, we're on number 6 right here. So once again, is there anything to pull out from all terms? There's a 3 and also an x, okay? So let me put the parentheses, let me put a 3x out here. What would be left on the inside? 3x times what gets us a 9ax to the third? 3ax squared, okay? And how about the middle term? When I go 3x times what will give me a 18bx squared? That'd be a positive 6bx, right? And last but not least, 3x times what would give us a 24cx? Plus 8c, because 3 times 8 is 24. Now, on the inside, is there anything else we could do? No, we can't. So that would be it, right? Let's jump to number 7. So number 7 on version A is number 1, I believe.
Oh no.
Okay, and like always, the first method we learned of factoring was pulling out the GCF, so that's what we're going to do. So the 6 and the 3, for sure, there's a 3 that we're going to pull out. And there's also R's and T's on both. Man, maybe let me make some more space here. So R and T, I do some weird T's on both. Now if I do pull out a 3RT, 3RT times what will get us a 6R squared T? 3R. Now if you're confused, just do a piece at a time. 3 times what will give you 6? Oh, that'll be 2. And then R times what will get us an R squared? R times R, so you need an R in there as well. I'm just showing you how you can do it a piece at a time if you don't see the whole thing at once. And the T you don't need, because T times, there's no other T. That's perfect because there's only one T right there. Now how about the other one? 3RT times what gets you a negative 3RT squared? Negative T. And that's it. So that is your answer for number 7. 3RT times 2R minus T. So number 8 on version A and B are the same. So at this point, we need to think. I know it's weird because there's 2 variables, but since it's just j squared, we know for a fact that you're going to have a j right here and a j right there. Now, let's ignore the k for a little while. Let's pretend that the k weren't there, all right? So if I put like, let's do this. So let's pretend that the k's weren't there. Then what numbers would belong right in here? In other words, what times what is negative 10 that if I add together is negative 9? Anybody? What times what is negative 10 that if I add together is negative 9? Negative 10 times positive 1. That'll give you a negative 10. And if you add it together, it will give you a negative 9, right? Now, the problem is that we really do have k's. So in order for us to get a k squared at the very end, we know it needs to be a negative 10k times 1k. So the only thing that's missing are the k's right here on the second term. That one's kind of weird. It had two variables, but it was on our homework. Anyhow, let's move on. So we're on the back side here. This one's so easy because the a value is 1, which means you could jump right into your factored form answer, put a w here, a w there. Why could we do this? Because w times w really is w squared. So all you need to do is think what times what is negative 56 that if I combine together it gives me a positive 1. That'd be a positive 8 times a negative 7, and we're done. Which one was this on version A? Version A, number 9. So number 9 was number 9. Let's move on, number 10 on version B. Right here we have an equation, guys, and it says solve. When we solve, we get answers, like as in p equals 5 or p equals 1/2. Some people didn't even put answers. They put the factored form, and that was it. So let's take a look at this equation. It's an equation because there's an equal sign. And we want to get something times something equals 0. That way we could use the zero product property to split. So what we're going to do is look at the right side of the equation. We're going to ignore the equals 0 for a little while. We're going to look at the the left side of the equation, and we're going to factor out anything possible. What could I pull out of there? For sure we could pull out a p, but how about the numbers? More than 2. 4. So 4p is the GCF. If you did 2p, I mean that's a common factor, but it's not the greatest common factor. So if you do pull out a 4p times what would give you a 8p squared? 2p. And how about 4p times what would give you a negative 4p? Negative 1. And that is it for the factoring, but let's not forget, if you wrote that in your answer, you don't get credit, because this is an equation that was set equal to 0, so it's still equal to 0. But now we know that we have something times something equals 0, so we could split them and set them each equal to 0. 4p equals 0, 2p minus 1 equals 0. That's a zero product property right there. And now we're able to solve each of those simple equations. And on this one, when you divide by 4 and divide by 4, 0 divided by 4 is still 0. So p equals 0, that is one answer. The other one, plus 1, 2p equals 1. Finally, we divide by 2, divide by 2. 1 divided by 2 is exactly that. P equals 1 divided by 2. In other words, 1/2. So those are the two answers you needed for number 10 on version B. Was this version A also, number 10? Version A. Let's move on to number 11. This one's too easy. Why? Because it's already in factored form. It's already equal to 0. All you have to do is split it and solve. So we have something times something equals 0. You're going to split it and solve. So the 4y plus 8 equals 0. If you subtract 8 on both sides, you end up with 4y equals negative 8. Why did I cancel that? Sorry, that's a negative 8. And then finally, our last step would be to get rid of that multiplication of 4 by dividing by 4. And you'll get y equals negative 2. That is one answer. That is really ugly. And the other one, we're going to add 4. Add 4. 3y equals 4. Final step. Divide by 3. Divide by 3. Y equals 4/3. 4 divided by 3. Those are the two answers to number 11. And it's the same for version A. Let's move on to number 12. Another equation, but this time it's not equal to 0. So the very first thing to do would be to make it equal 0 by subtracting that number 56. So of course you can't subtract 56 from t values, so we're just going to rewrite it. T squared minus 26t minus 56 equals 0. And then we're going to factor, split, and solve. Now the reason why I could set this up with the t and a t is because t times t is t squared. Remember, we love it when there's no number right here in the front. There's an invisible 1, and we're able to just set this up and think, what times what is negative 56? That if I combine together is negative 26. So in order for us to clearly see this, it might be a good idea to set up a list. Negative 1 times 56, negative 2 times 28. And you know what? I want to stop right there because I already know if I combine these guys, it gives me a positive 26. But I really need a negative 26. So that's simply changing the sign to a positive 2 times a negative 28. And then these numbers simply go right in here. Positive 2, negative 28. And now that we have it in factored form, now we could split them and solve. I want to set this one equal to 0, and I'm going to set this one equal to 0. And then we're going to solve both of them. Minus 2. So t equals negative 2. That is one answer. And also 28 is going to be the other answer. T equals 28. This one was also for version A. It was also number 12. So we're on number 14, version B. But on version A, this is number 16. So if you're on version A, it's the last one. Okay, so right here on number 14, it is a quadratic trinomial. You can't factor out anything. So we are going to go with the long process. Step 1, a times c. That's 8 times 3, that's 24. And then we want to think of the multiples of 24 that combine together to give us a negative 10. So I want to go one at a time. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And right there I see that 4 and 6 combines together to give me 10, but I want it to be a negative 10, the b value. So I want to change both the negative on the 4, and I want to change that 6 to a negative 6. So this is the correct pair of numbers that we want. And we're going to use the shortcut. The shortcut, instead of factoring by grouping, would be to take that aq squared and just write it aq, 8q, and 8q, and then plug in the minus 4 and the minus 6. And that's your answer format. But we're going to reduce both binomials, and in this case the first one by 4 and the second one by 2, I believe. Yeah. So the first binomial will become 2q minus 1. The second binomial will be 4q minus 3, and it's still equal to 0. So at this point, we're able to split them. So I'm going to write 2q minus 1 equals 0, and 4q minus 3 equals 0. 4q, sounds like a bad word. Okay. The first equation, plus 1, 2q equals 1. And the final step there is going to be divided by 2, which means q equals 1/2. The other one, plus 3, you're going to have 4q equals 3. You're going to divide by 4. Q equals 3/4. Sorry about the horrible writing. All right, number 15, version B and version A. Let's solve it. Once again, you have an equation. You want it to be set equal to 0. So we're going to move everything to one side, set it equal to 0. So I am going to get rid of the minus 7y by going the opposite, plus 7y. That'll cancel it out, plus 7y. And then I want to get rid of the minus 2 all at once by adding 2 and adding 2. So of course I have the equal sign. Let me write it over here. And 0, because there's nothing left on the right side. And on the left side, I'm actually going to take all of this right here. Since I can't combine it, I'm just going to rewrite it. 6y squared plus 7y plus 2 equals 0. And now we can't pull out a GCF, so we're going to have to use the longer process. Step 1, A times C is 12. Step 2, think of the multiples of 12. 1 times 12, 2 times 6, 3 times 4. Which pair of numbers combines together to give us 7? That would be 3 and 4. Step 3 is to write it in our answer format. And the answer format will have a 6y right here and a 6y right there. Of course, we just didn't write the 2, we just wrote 6y. And we are going to reduce them later. And then we take the 3 and put the 3 right there, and take the 4 and put it right here. And let's not forget to reduce. So we need to reduce whatever possible. On the first one, we reduce by 3. So we will get 2y plus 1. And the second binomial will reduce by 2, and we get 3y plus 2, and then equals 0. And now that it's in factored form, equal to 0, now we could split them and solve. So I'm going to take this one and write it over here, and this one write it over here, set them each equal to 0. And now at this point, we solve it. Minus 1, minus 1. 2y equals minus 1. Final step would be to divide by 2, divide by 2. So y equals negative 1/2. The other one, subtract 2. We get 3y equals negative 2. Final step, divide by 3, divide by 3. And y equals negative 2/3. Those are your two answers. Final question. Thank goodness. Number 16, which I believe is number 14 on version A. Let's get it set equal to 0 plus x. That way it will be equal 0 plus x over here. And I'm just going to rewrite it. It's going to be 12x squared plus that x that I just put right there minus 1 equals 0. And once again, we go through the steps. Step 1, a times c. That will be negative 12. Step 2, think of the multiples of negative 12 that combine together to give you the middle value, which in this case, the middle value is positive 1. So let's make a list. We have negative 1 times 12, negative 2 times 6, negative 3 times 4. Now, if we do combine the negative 3 and the 4, we really do get that b value of 1. So that's the correct pair of numbers that we want. So what we're going to do now is rewrite the equation, but in factored form with the shortcut. We simply take the 12x squared, ignore the square, and just put 12x here and 12x there. And then we take the pair of numbers from step 2, put the negative 3 right there, and put the positive 4 right there. Or you could do it the other way around if you want. It doesn't really matter. And then after that, we reduce each of the binomials by the GCF if it's possible. So we're going to divide this first one by 3, both of them, and we will get 4x minus 1. And the second binomial we're going to reduce by 4, and we will get 3x plus 1, and it's still equal to 0. So now at this point, I could split them. I'm going to put the 4x minus 1 equal to 0, and I'm going to put the 3x plus 1 equal to 0. And then we solve both of them. So plus 1, we will get 4x equals 1. Final step would be to divide by 4. So we get x equals 1/4. That is one answer. And then we subtract 1 over here, subtract 1 over there. We'll have 3x equals negative 1. Then we divide by 3, divide by 3. So x equals negative 1/3 is the other answer. And that's it, guys. That's a half-hour video explaining every single question on this quiz. These exact questions will pop up on Friday's test.